The next topic of discussion on electrostatics is distribution of charges. Consider two spheres, namely A and B with different radii R1 and R2 respectively. These two spheres are connected by a thin wire. The distance between these two spheres is greater than the individual radii of the spheres. If a charge Q is introduced to any one of the sphere, this charge is redistributed in both the spheres so that the electrostatic potential in both the spheres are same. So we can say that the spheres are in electrostatic equilibrium. Let Q1 be the charge that is residing on the surface of the sphere A and Q2 be the charge that is residing on the surface of the sphere B. So we can say that the total charge Q equal to Q1 plus Q2. The electrostatic potential on the surface of sphere A can be written as VA is equal to 1 by 4 pi epsilon naught Q1 by R1. Similarly, the electrostatic potential on surface of sphere B can be written as VB equal to 1 by 4 pi epsilon naught Q2 by R2. We said the two spheres are in electrostatic equilibrium, which means that VA is equal to VB. So that 1 by 4 by epsilon naught Q1 by R1 is equal to 1 by 4 by epsilon naught Q2 by R2. So cancelling, finally we get Q1 by R1 is equal to Q2 by R2. Consider this as equation number 1. The charge density on surface of sphere A is sigma 1 and charge density on surface of sphere B is sigma 2, which implies that Q1 is equal to 4 pi R1 square sigma 1 and Q2 is equal to 4 pi R2 square sigma 2. Substituting these two in equation 1, we get 4 pi R1 square sigma 1 by R1, which is equal to 4 pi R2 square sigma 2 by R2. So finally we get 4 pi R1 sigma 1 is equal to 4 pi R2 sigma 2. 4 pi and 4 pi ruled out. So finally R1 sigma 1 is equal to R2 sigma 2, which implies that R sigma is a constant. So from this we can say that the surface charge density on the spheres are inversely proportional to the radii of those spheres. Consider a charge conductor of irregular shape. We know that smaller the radius of curvature, larger the charge density. So a sharp edge of this conductor has large number of charges, which results in very high electric field. So this electric field ionizes the air around it. So the charges at the edge of the conductor repels the positive ions in the air and attracts the negative ions in the air. As a result, the total charge at the edge of the conductor is reduced. This we call it as action of point or corona discharge. Lightning arresters or lightning conductors. These devices are used to protect tall buildings from lightning strikes. They work on the principle of action at points or corona discharge. The device of the lightning conductors consists of a thick, long copper wire which runs from top to bottom of the building. The upper end consists of sharp spikes or needle. The lower end is connected to a copper plate which is deeply buried inside the ground. When a thundering cloud passes the building, the negative charge induces positive charge in the spike. As the curvature of the spike is very small, the charge density on the spike is very high, such that it produces very high electric field which is capable of ionizing the air around it. So, due to corona discharge, it absorbs a negative charge, and these negative charges are diverted safely to the ground through the copper plate which is deeply buried inside. So, the lightning arresters does not stop the lightning, it just diverts the negative charge safely into the ground. So students, the chapter gets over with this topic. So see you soon with next chapter, that is current electricity.